Hi, thanks. I'm wondering about the last thing you talked about, the safe set generation and the methodology there. So you did the synthesis first for all instructions, and then you make this graph and try to find the minimal set. But the goals are different, right? In the synthesis, you're trying to have like a simple synthesis using that's close enough. So you might have like two instructions that you can do add with subtract, and you can do subtract with add. Then either one of them is necessary, but couldn't you do both of them with some other instructions where you don't really need either of those to be safe?
Of course. So the synthesis process is repeated many times for every instruction to generate many possible translations. So one of the translations may be add uses subtract, subtract uses add. But then when we try to synthesize more translations, we exclude those used instructions to see if we can generate any more translations. So in fact, the synthesis process is repeated for every instruction multiple times to generate as many translations as possible before building the synthesis graph.
So my understanding is that you want to synthesize using the safe instructions. Right. But is it possible to have a combination of safe and unsafe instructions which are themselves safe?
Yes,
I mean, if you only use unsafe, yes, it's unsafe, right? I think it's not even clear whether if you have a sequence of unsafe instructions, whether it's unsafe.
Right, I think that's a very good point. So in this work, we don't assume there's any context, and each instruction is either safe or unsafe in its isolation. And like you mentioned, there may be cases where two safe may interact and become unsafe. Similarly, two unsafe may actually indeed be safe. But we don't consider that in our synthesis process. So here, when we say we have a specification for safe or unsafe, it's either safe or unsafe in all contexts. So we don't make the distinction. But I think that's a great point, and that's a line for future work, where we can look at more sequence of instruction rather than looking at individual instructions.
One could imagine a flag in a microarchitecture where you could have a mode where it does the micro-ops which are safe when you don't need maximum performance, and does it the other way when you do. Right? So it could be kind of done dynamically. Of course, you still need to know the translation.
Right, I think that's a very good design point. And one of the things that we did discuss and have a small discussion paper is we could have these translations in hardware micro-ops, where depending on if the mode bit, like you mentioned, is set or unset, we could either like translate them into simpler opcodes versus you don't do it.